Hello. So today also we will continue solving problems on projectile. So a 2-meter tall basketball player is standing on the floor 10 meters away from the basket. Okay, so he is 2 meters tall and he is 10 meters away from the basket. What is this 10-meter distance? What is this 10 meter? This is delta x. Okay, we have to put in mind that this is delta x. So they're giving us the range for delta x from beginning to end. It's 10 meters. Okay, he shoots the ball at a 40 degrees angle. So we know theta with the horizontal. Okay, so he shoots the ball. This is vector v initial. This is vector v initial. It's a vector. Okay. It's at 40 degrees with the horizontal. Okay, we know the angle, but we don't know the value of the initial. The height of the basket is 3.05. The height of the basket is 0.35. So he is 2 meters long. He is 2 meters long, and the basket is 3.05 meter long. Okay, and he's shooting the ball from this height to this height. Okay, part A. Write the equations of the horizontal and vertical displacement. Okay, this means he's asking for the equation of delta x, the equations of delta x, and the equation of delta y. And these are here, the equation of delta x and the equation of delta y. So he wants me to write the equation. So I need v initial x and v initial y. Okay, can I get what is v initial x? Let's see. So v initial x is equal v initial cosine of the angle theta, which is 40. This is equal to 0.766 v initial. Okay, we don't have the value of v initial, so we just put v initial. V initial y is equal v initial sine 40, and this is equal 0.64 v initial. Okay, this is v initial x, v initial y. We don't know what is v initial, so we just leave it like this. Now, what's the equation for delta x? Delta x is equal v initial x times delta t. So this is equal to 0.766 v initial delta times delta t. Okay, and delta y is v initial y delta t. So it is 0. You can directly put it here. Okay, v initial x delta t. Here it is v initial y delta t. So we can put it directly. It is 0.64 times delta. So 0.64 times delta t minus 5 times delta t squared. This is part A. This is what is asking for. Just the equations. Okay? And since they are equations, it means there are a function of here. We can just remove this with the initial x delta t. We know it from up here. So we know that delta x is 0.766 the initial delta t, and delta y is 0.64 delta t minus 5 delta t squared. This is part A. Part B. Part B. At what initial speed must the player throw the basketball so that it goes directly through the hoop? So we want to calculate the initial. Okay, and he's saying He's saying so that the ball goes through the loop. This means how much, this means, so let me put it again. Part B, the initial equal how much, so that delta x equal 10 and delta y equal this distance. It goes through the loop. It means from where he hit it till it reached the loop. So you just imagine here that there is a straight line from its height, so till here. Okay, so how much is this distance? The loop is at 3.05 and he is at 2. So delta y is equal to 1.05. Okay, so we come to our equations. Delta x is 10. Okay, so this is the first equation. Let's see what to do. This is the first equation, right? So instead of delta x, I will put 10 equal 0.766 the initial. Let's call it t instead of keep delta t. Okay, this is equation 1. And the second equation, 1.05 is equal to 0.64 v initial times t minus 5 t squared. Okay, this is equation 2. How to solve these two equations? One way to solve it, these are two equations in two unknowns. How I would solve it is as follows. I see that here I have the initial t, and here I have the initial t. So from equation 1, I get the initial, from equation 1, the initial t is equal to 10 over 0.766, right? This is from equation 1, and this is equal to a number, 10 over, yeah, so this is equal to 13.055. This is from equation 1. Now, from equation 2, I have 1.05, it's equal to 0.64 v initial t, the same value of v initial t, which I have just calculated it. So v initial t is 13.055 minus 5 t squared. Okay, let's solve this. Let's have some space here. So from equation 2, I have this. Let's solve this. So 1.05 is equal to 0.64 times 13.055 is 8.355. Okay. Minus 5t squared. 5t squared, I take it to the other side. 1.05, I bring it to this side, and I will get, in the end, t equal to 1.208. Okay, so what I did here, 1.05, I bring it to the other side. 5t squared, I bring it to the other side. Then I divide by 5. And then I take radical, and I get t equal 1.208 seconds. Okay, so this is t, but I know that v initial t, where is it? It's here. I know, let me just erase this. I know that v initial t is 13.05. So I plug this t over here. I plug this t over here. I plug t in this equation, and I get the initial. So the initial times the initial times t, which is 1.208, is equal 13.055. You just divide 13.055 by 1.208, and you will get the answer to be 10.8 meter per second. So implies initial value. Okay, this is part B. How much is the initial? So the trick was using these two pieces of information, delta X and delta Y. Okay, because he gave me delta X and delta Y. So I just put, instead of V initial X, its value, it's 10. Sorry, Vx, delta X is 10, delta Y is 1.05, and I plug in the equations, and then I solve for T, and from there I get the initial. Okay, so this is part B. Let's do part C. Part C, find the maximum height with respect to the ground. So here you always have to put in mind, so let's do it here. Maximum height implies V final Y equal to 0. Okay, this is how I do maximum height, and the equation I use is this. So I use this equation. Instead of VFY, I will put 0 equal to V initial Y. What is V initial Y? Here, V initial Y is 0.64 times V initial, which is, now I know it from the previous part, it's 10.A squared. So all of this square okay, minus 20 delta minus 20 delta Y. Okay, so with this, I'm calculating the distance from here to here, from where it left the guide. So this is delta Y I'm solving for now. Okay, I continue the equation. So in numbers, I have 0 equal 47.78 minus 20 delta Y. I take delta Y to the other side, 20 delta Y equal 47.78 implies delta Y equal 2.4. Okay, implies, because the question is find the maximum height with respect to the ground. With respect to the ground, I have to add this extra distance from here to here. So maximum height is equal to 2 plus 2.4 . 2 plus 2.4 implies height equal 4.4 meters. Okay, so this way, after we calculated delta Y, we added to it the height of the guy, because this delta Y is from where he hit the ball till where it reached the loop. Okay, so this is the full solution to this problem. This is exercise 9, page 18 in your booklet. I would suggest for next time. So here you will find the full solution, okay? So here, what is the given? This is delta x, it's 10 meter. Here I don't have the initial, but I have the angle. This is 1.05, the delta y. I put all the given. And this is the full solution, how I did the calculation. Now I would suggest is that you solve on your own, solve problem 1 on page 19. Okay, it is solved already. It is solved, so you just have to hide the solution. So solve problem. So do solve problem on page 19. It is solved. Hide the solution. Hide the solution and try to do the calculation to solve the problem on your own. Okay, that's it for today, and have a good weekend. Just one more thing. If you have any questions regarding any of these lectures, don't forget to send me an email or just write a comment under the lecture. So as in the live sessions, I go through your questions. Okay. Okay. Have a good weekend.